Hi, welcome to Pre-Calculus. Today's topic is finding the nth root of a number, problem type 2. So what we are after is that we are trying to solve x to power of n is equal to some given number, say a plus bi, and we go figure out that a plus bi is equal to the following polar form or cosine of theta plus I sine of theta. And the solution by application of De Moivre's formula is x is equal to these n numbers. The numbers are created by taking k to be number 0, 1, 2, 3 all the way to n minus 1. So very similar to the previous lecture, except that in the previous examples, right hand side was just either a real number or pure imaginary. And now we are taking a look at situations where the right hand side is a complex number, it's a mix of real and imaginary numbers. Questions that you see are just x squared equal to a number, or x to the power of 4 equal to a number, with the other powers creating a bit of a challenge for us, and we are pushing them aside for a moment. So where do we start? Right hand side is given. We want to solve x squared equal to this. From outset we know that we are going to have two solutions. Just like if you had x squared equal to 4, you have 2 and minus 2. Here also two solutions are going to be created at the end, and they are going to be away from each other by 180 degrees. So how do we proceed? First, we write our number in the polar form. So minus 1 plus radical 3i. I have to write it as r times cosine theta plus I sine theta. What is the role of r and theta here? Again, a picture is going to help. Hopefully your hand is steadier than mine. So here's my y-axis, a little bit more presentable, and x-axis. So I have minus 1 and plus radical 3. So 1 and say radical 3, that's where I'm headed. So this is my right hand side. This is minus 1 plus radical 3i. We have seen this number several times. Do we recognize what is r and what is theta in this problem? How do we get the r? So if I have a plus bi, r squared is equal to a squared plus b squared. So in this case, r squared is equal to minus 1 squared plus radical 3 squared. Of course, 1 and 3 makes a 4, and r is just equal to 2, just a positive root of that 2. At what angle is it? Well, if it gets 120, you're right. That one comes from tangent. Tangent of theta is equal to b over a. So we are solving tangent of theta equal to b is radical 3 minus 1 is minus radical 3. We recognize this point is in the second quadrant. What angle in the second quadrant has tangent equal to minus radical 3? That's of course 120 degrees. Okay, now we attempt to find the square root of this thing, or solve x squared equal to this. There are two solutions. Step 1, we find r to power of 1 over n. So in our problem, 4 to power of 1 half. So of course here, let's write out from the outset, our n is equal to 2. This is the n. So our Excuse me, let me make a correction here. Yes, r was 2. So 2 to power of 1/2. It's easier way to write it as just radical 2. Theta divided by n, our theta is 120 degrees, divided by 2, that's also 60 degrees. Now we are going to form our formula. Our formula says what? R to power of 1 to power of n times cosine of theta over n plus 360 over n times k plus I sine of same thing, theta over n plus 360 over n times k. Our k runs from 0 to n minus 1. So r to power of 1 over n is just radical 2. So I write radical 2. Cosine of theta over n is 60 degrees. 60 degrees. How about 360 over n? 360 over n, just 180 degrees. So 180, first choice of k is just 0. I sine of same angle, so 60 plus 180 times 0. Let's simplify. Radical 2 cosine of 60 plus I sine of 60. So that's going to be radical 2 1/2 plus I radical 3 over 2. We might as well leave this as it is. Radical 2 plus I radical 6 divided by 2. So this is one of the roots. How about the other one? We keep going. K from 0 to n minus 1. My n is 2, so we stop at k equal to 1. So the next solution is radical 2 times cosine of 60 plus 180 times 1, which is 180, plus sine of same thing, 60 plus 180 times 1. Let me simplify here. So it's going to be radical 2. So essentially we are moving by 180 degrees. Wherever this thing is, we move diametrically opposite to that. And so that's going to be radical 2 times cosine of, this is 240 degrees, and the cosine is going to be minus radical 2 over 2. And sine of 240 degrees also, excuse me, I went ahead of myself. Cosine of 240, so that's minus 1/2. Sine of 240, that's going to be minus radical 3 over 2. So all that has happened is that it's just a negative of this. That's always the case for solving x squared equal to something. X squared equal to something, whatever solution you get, you can simplify, simply multiply it by negative. So if I multiply this thing by, I get minus radical 2 over 2 minus I radical 6 over 2. This is the second root. So for x squared, we have an easy way out. You find 1. The second one is just a negative of that one. We could have expected that, because when you take that negative and square it, you get positive 1. So these are the two roots. Here's another example. This one is the fourth root of something. So we are given our z is, so the number that we are given is a+ plus bi is now minus 2 radical 3I. What is the r of this? R comes from this formula, so r squared is minus 2 squared plus minus 2 radical 3 squared, so 4 times 3, 12, 16, so r becomes 4. N is obviously, n is 4. Theta, tangent of theta is b over a. Tangent of theta is going to be b minus 2 radical 3 over minus 2. So that is radical 3. So normally we would have said the angle theta is 60 degrees, but remember this is in the quadrant 4. Minus 2 or minus 2 radical 3 is somewhere here. So this is 60. That means the theta itself is 180 plus 60. So if I were to write this number in polar, it could have been 4 times cosine of 240 plus I sine of 240. Okay, now what is theta over n? Theta over n is 240 divided by 4. That is 60 degrees, another friendly angle. What is 360 divided by n? That is 360 divided by 4. That's the degree by which we turn to go from one vertex to another vertex. Now what's our solution? Our solution is r to the power of 1 over n times cosine of theta over n plus k times 360 over n, and I times the sine of the same angle. Where k are the numbers 0, 1, 2, all the way through n minus 1. In our case, well, let's go put everything. I have my r is 4, so 4 to the power of 1 over 4 cosine of theta over n, here's theta over n, 60, plus k times 360 over n, that is 90, and the same for the sine, 60 plus k times 90. Now my k are numbers 0, 1, 2, and 3. We stop at 3, we just have 4 of these things. So 4 to the power of 1 to the power of 4 times cosine of first one. So let's take turns. K equal to 0, cosine of 60 plus I sine of 60. So that's going to be 4 to the power of 1 over 4. We could perhaps simplify a little bit. 2 squared to the power of 1 over 4 is 2 to the power of 2, 1 over 4. It's 2 to the power of 1/2. So that's a little bit easier to talk about. It's just square root of 2. This is square root of 2. Cosine of 60. What is cosine of 60? Cosine of 60 is 1/2 I radical 3 over 2. So I get radical 2 over 2 plus I radical 6 over 2. Radical 2 times radical 3 is radical 6. Next, we take k equal to 1. So that means, we agree to write this thing as radical 2 cosine of, now we add k equal to 1, we add 60 to this, add 90 to this, so I get 150 plus I sine of 150. So this is radical 2 times cosine of cosine of 150, what's that? Minus radical 3 over 2, and then sine of 150, same as sine of 30, is 1/2 So minus radical 6 over 2 plus I radical 2 over 2. Going up, k equal to 2. By now we know that we are turning 180 degrees from that, so we expect our answer is going to be negative of this. Let's see. Radical 2 times cosine of, we're adding 180 to that, so that's 240 plus I sine of 240. So how did I get 240? 60 plus 2 times 90. So 60 plus 180 is 240. And radical 2 cosine of 240. So that's going to be minus radical cosine of 240. What was that? It's minus 1/2. Sorry. Sine of 240, that's going to be minus I radical 3 over 2. Multiplying, we get minus radical 2 over 2 minus I radical 6 over 2. As we said, it has to turn out to be negative of this. So we could have saved time, and k equal to 3. This one is turned from that by 180, so we expect this to become negative. Let's see if that guess is correct. So I take k equal to 3 and put it here, so that's going to be 270 plus 60, so that's going to be cosine of 270 and 60 is 330. So radical 2 times, this is minus 30 degrees, so it's has to be plus radical 3 over 2 sine of minus 30 degrees minus I times 1/2. I get radical 6 over 2 minus I radical 2 over 2, which again nicely is just a negative of that number. So with even exponents, our numbers come in pairs, one positive, one negative, etc. So when we want to write the answer, we just list these four separated by comma, and we should be done. Okay, so we learned how to take a root of a number. So a number is given to us in the standard form. We write it in the polar form. Sorry, the screen is sensitive. We write it in polar form. Then we get an r and theta. R and theta. R is raised to the power of 1 over n. Theta is divided by 1 by n. And then we turn by angles of the polygon, which is 360 degrees divided by n. We have to have n roots at the end. Okay, so that concludes our lecture, and I wish you good luck, and God bless.